Welcome back to Roland Tutoring. If this is your first time joining us, please take a moment to hit the subscribe button. If you would like to send in your problem or inquire about one-on-one tutoring, contact us by one of the methods listed in the video description. Today we are working on a fluid mechanics problem, specifically how to calculate the density, specific weight, and specific volume of air at 50 degrees Celsius and 3,400 millibars absolute. So the first thing you'll want to do is grab your book and find your table. It will look something like this. So we'll go ahead and go down. We find air here is 287 meters squared per second squared degree Kelvin. So we will write that down. We get R equals 287 meters squared per second squared Kelvin. Then we can go ahead and go back to our equation sheet here for our perfect gases equation, and we'll use this one right here. And our specific weight is equal to a gravity times pressure over R times T, which gives us 9.81 times our pressure, which was 3,400 millibars absolute, which is the same as 0.340. Let me check the units for you here just to make sure that's right. Kilonewtons per meter squared. And our 9.81 is in meters per second squared. Just in case you need those, our R, we have 287 meters squared per second squared degree Kelvin times degrees Kelvin, which is 50 plus 273. So we can go through and look at our units here. Second squared and second squared should cancel. We get a 1 meter here, so we have kilonewton per meter on the top over meter squared, which turns into kilonewton per meter cubed. That'll be our final unit. Now we can go ahead and do the math of 9.81 times 0.34 divided by 287. Get our parentheses in here. 287 times 50 plus, and that's why you need parentheses, so make sure you use them. So I'll go back and do 50 plus 273 times 287, and that'll be our number on the bottom. And on the top we'll get 9.81 times 0.34 divided by that answer to give us this longer number of 0.12345, which in turn turns into 3.6 kilonewtons per meter cubed. And part of the reason is if we had used this, this number could stay at 3,400. So if we put 3,400 in here instead, because 1 bar equals kilonewton per meter squared, as I said, but if we had left that in there, we would get 3,400 times 9.81 divided by 287 times 50 plus 273, and that gives you the same number moved over here. So that will be your final answer. Moving on, we rearrange kind of our same, we can come back here, use this same kind of equation. So now we are looking for the density and also the volume. So we will use our pressure over density. I'll copy this equation down. Our pressure over density, try and make that look less like a P there, equals our pressure over volume equals RT. So we'll use each of these parts separately of pressure over density equals RT. And we want our density here, so we get pressure over RT equals our density. And once we put that in, we know our R is 287 times our 50 plus 273, which should give us 323. And our pressure is back to that 0.340. We plug all of that in. We should end up with our pressure, remember, is in kilonewtons per meter squared. Our R is meters squared per second squared Kelvin. We have Kelvin, Kelvin, Kelvin. Our meter squared. If we continue here with our same equation, sorry for the brief interruption there, we get 3.67 kilograms per meters cubed, and that is our density. We can move on to our volume of, if we look at this same equation, we get pressure times volume equals RT, which gives us our constant times temperature over pressure. We can go ahead and continue filling this out by 287 times 323 over 340, and we'll plug that in. 287 times 323 divided by 340, and then divide by 1,000 to get it into kilograms. Here we get our, so otherwise you could also do this, something like that, and we could go back and do that up here as well. So that will show the importance of converting that millibars to our kilonewtons per meter squared right away. So this will give you 0.273 meters cubed per kilogram, and that will be your final answer. Like I said, if you need more help or are looking for tutoring or to have your problem solved on our channel, please message us or contact us via one of the methods listed in the video description. Thank you and have a wonderful day.